Hey everyone, this is Andrew and here's another information for you. Thresholds are points where a function changes differently. We can see this a lot in different functions, but I have to say that there's an application when it comes to neuroscience, finding how axons react, and in that case you can research more about it and there's even more complex functions for you to discover. But to put it in a simple way, we can use this function y equals e to the x. So e is continuous, showing continuity. And we can write that, or rather draw that, with a graph. We can know that there's an asymptote at the x-axis. And then this area is 1. Where's the threshold? Basically it's everywhere, because it's changing continuously. The tangent lines, which are the instantaneous rates of change, they don't seem to be the same for every x value in this function. So what does this mean? Okay, that means that dy dx, which is the first derivative, equals e to the x, and therefore d to the n of y over dx n is still equal to e to the x. Okay. Now what about this function? So suppose we have a function like this, where there's a line, it doesn't change, but there's still this curve. And okay, let's do a point, because it covers two types of points. Now, where's the threshold? Okay, it changes here, but it doesn't change over here. So there's a specific area in which it doesn't curve. And over here, since that there isn't an area to compare on the left, you can still compare to the right, as long as we don't have this. This is not continuous. If you how do you describe it? If there was an ant on this function, it's not going to reach the other side. Okay, let's forget about the steepness, but this undefined region, it basically messes up our tangent lines. So now, okay, this interval has a threshold, or this interval is where the threshold is, or where all thresholds exist on this function. So now, what's the easiest type of threshold? Oh, it's like this. It's a piecewise function. We can call this f of x. It's obvious to state where the threshold is. It's right there. We can call this x sub delta. Now, again with the piecewise function, it's two different functions, a of x and b of x, and then we can define the domains where it should be using x sub delta. So a of x is less than x sub delta, and then for b of x is greater or equal to x sub delta. Let's see. We can already rule out the continuity aspect. We can represent this by doing such that, okay, what's the first condition? You can say, how would you do it? I might be wrong here, but I might do this. It maps to continuity 1. Wait, f of x doesn't equal that? So, well, it has to be. It's continuous for all values of x and y. And now, what else do we need to know? In order to have one threshold point, it has to not be differentiable. And we can find that where the limit of the speed, or of the rate of change from the left and the right, are different. So we can do limits, which is simply approaching y values, but there's a lot more complications with that, where x approaches x sub delta of a prime of x. So this is from the left. So if we have to do a minus sign, it's not a minus sign. We can do minus equals the limit of, or as x approaches x sub delta on the right of v prime of x. Or rather, it doesn't equal that. Because they're different. That's why it shows difference. It's a significant change, basically. And that's about it. Thank you for watching. Continue learning more about math.